Once again, good morning, everybody. Today, I'm going to talk you to talk about the analysis of method and analysis for the harnessing of solar energy related to photovoltaic systems. So we have a lot of things to know about. So I already talked about me, and there are a lot of important concepts that we should see that are related to photovoltaic system, and we should know how to make the analysis of solar resources and the available technologies for the harnessing of solar energy, and see how is a basic PV energy conversion system, and how to design a PV system, and so on. So, me, Robenson Jean, I'm going to present you the stuff. So, we have to know that nowadays there is a problem with the energy sector. The problem is related to what we use as fuel. So, in many countries, we have this problem of CO2 emissions, and that is a very big problem. And we know that the consumption of fossil fuel is damaging our environment or planet. And also, as an alternative, we have the renewable energy. As renewable energy, we can mention the wind energy, the solar energy, geothermal energy, biomass energy. But one of the renewable energy sources that is really available is the solar energy system. And this is available everywhere, and we have the technologies to harness this kind of energy, and it is really useful, as it can help us to set economical goal, environmental goal, by reducing the CO2 emission and doing a great energy transition. So when talking about solar energy system, we have to take into account the available technologies, the possible application, and the current trends, and also the actual investigation that is being done on this field. So let us see what is a photovoltaic system. A photovoltaic system is a sort of component where we use photovoltaic modules to convert sunlight into electricity. But for doing that, we use a process that is called photovoltaic process. And we have to know that to harness solar energy, we can use the photovoltaic process, and we can use thermal process. But now we are going to talk about the photovoltaic process. And to use this process, we are going to use such equipment like controllers, MPPT, and inverters, and other equipment that is useful for the harnessing of solar energy. And once we are making this transformation from sun to electricity, and we are going to use the power conversion system in order to inject it into the grid, or to use it in our own house. So the goal is to use this electricity by the means of the loads, like on the electrical loads. So first of all, we have to know that the sunlight that we use to produce the electricity, so it is a form of renewable energy. But what is a renewable energy? Renewable energy is all type of energy that comes from a natural source whose generation rate is higher than the consumption rate. So if this is not true, so we don't have renewable energy. For instance, we can see the the wood, the wood for example, the energy wood. So if the rate of consumption of the wood is not higher than the rate of regeneration of the forest, so we cannot say that wood as biomass is renewable energy. So to consider it as a renewable energy, the rate of consumption should be less than the rate of generation. Okay. And nowadays, the trends are in favor of solar energy and wind energy. As first, together, they represent 10.3% of contribution of global electricity production, 3.7% for solar in 2021, and it was 1.1 in 2015. So there is a big progress, and we can hope that in 10 more years, the progress will be better as we have much more technologies available. There is a advantage. There's many advantages in using solar energy. The advantage is, as I said earlier, there is no fuel consumption. So as there's no fuel consumption, no CO2 emission, and the maintenance is minimal. There's no noise for the production, as we can imagine for fossil fuel power plant, like a thermal power plant. There is a lot of noise if someone is living near fossil fuel power plant. At the moment of generation, there is a lot of noise, but we do not have that with a solar power plant. But if we have advantages, there's disadvantages. The disadvantages is the cost of the technologies that is still a little bit high, and the efficiency that is a little bit low, because nowadays the efficiency, the global efficiency is around 17%, 18%, but in investigation field, I have some friends here and at the UNAM who can reach the 23% of efficiency, but it is still in the field of in the area of investigations, not a product that are already commercialized. And also the required surface. The fact is, it is one of the biggest problems. The fact is, we need a lot of surface to produce an acceptable amount of energy. So it is one of the disadvantages of solar energy. But if we have a surface, it is not really a problem. So we're going to see some important concepts before going further on the photovoltaic technologies. So we have to know what is the sun, because the light we are using comes from the sun. So let us see. Okay. The sun is a source of energy, and there's not something that is going to end tomorrow. So we will still have the sun as the renewable energy sources. And the sunlight is a flow of energy that comes from the nuclear reactions of the sun, and which is the Earth's surface in the form of electromagnetic radiation. But what is the irradiation? So we have two terms. We have irradiance and irradiation. The irradiance is in terms of power, and the irradiation is in terms of available energy by unit of surface. So when does irradiation arrive on the Earth's surface? On a given surface, we have an amount of power that a captor can have. But in terms of time, when we have this power in terms of time, so we have energy. That's why the unit is the unit for irradiation for the unit for irradiation is watt-hour per square meter. And now let's see these images. So we can see here we have the sun, and here we have the captor. So what we have here is direct radiation. So these radiation arrive without being disturbed, but those were disturbed by some particles like cloud. And after what we have, the rest is the diffuse radiation. And when the sun ray touch the ground and after get to the captor, so we have a reflected radiation. And all we have on the captor is the global radiation, is the sum of all of this. But what is the most important is the direct radiation, and the amount of energy that we receive is mostly due to the direct radiation. So let's see what happened in a photovoltaic model. So in a photovoltaic model, we have this effect, the photovoltaic effect, that is the conversion of the sunlight into electricity through a basic unit called a solar cell. And it is made of semiconductors. So the basic unit of a photovoltaic module is the solar cell. That is the place where the generation of electricity by photovoltaic effect is carried out. So if we have to collect solar energy, we have to measure what is the available energy on this place, because if the energy available on the place is not interesting, so I have no interest to involve myself in the construction of a solar power plant in this place. So we have to know if how much is it, how much this energy is. So to do that, there is such instrument to make the processor. We have a pyrometer. The pyrometer is an apparatus that measures the global radiation that we have seen before. So it is the sum. It is the sum of all of those irradiation, and we have the pyriometer. The pyriometer is an apparatus that measures the direct radiation that is the most important, that comes directly without disturbance to the model. And we have another unit that is the peak sun hour. The peak sun hour is an energy measurement unit that we use to specify irradiation, considering the collector that receives an irradiance of 1,000 watt per square meter for 1 hour. So 1 peak solar hour is 1,000 watt hour per square meter. So it is an important unit that we are going to use for the calculus. Now let's see the analysis of solar resources. So first of all, we have the measurement that is very necessary in order to know how is the spatial distribution or the spatial resolution of the available energy, in order to estimate or to approximate the energy production of photovoltaic solar power plant. So it is important to know that we have some useful tools where we can go in order to have an estimation or an approximation of the available solar energy in a given place. That's why we have some solar irradiance map. But to do that, we have to know some data like the geographical coordinate and the climatological data of the place where we are living or where we are going to implement this power plant. And as useful tools, we have these tools of La NASA, that is this website where we can go. And once we have the geographical coordinate of the place, so we are going to enter this data, and on this website, we are going to see what is the historic of what was the evolution of the temperature, the main temperature, the average temperature on this place, because the temperature, the ambient temperature is useful for the design of a solar power plant, and we are going to see the irradiance. That is very important to do the design to approximate the available amount of energy for a given surface. And we are going to see also what is the range of time where the sunlight will be available, or where we can harness an interesting amount of energy. And also we have the ERA 5, that is another database. And here in Mexico, as I'm living here in Mexico, and in Mexico we have the Conagua, that is another great database that is useful for doing the estimation of the solar resources. So here it is we have an example of such studies. So in terms of modes, so I have the irradiance for the historic for the year of 2019 for the place where I'm living. I'm living here in a city near Mexico City, and at this place, so we can see that in May of 2019, so we had around 6,000 watt-hour per square meter as irradiation. So it was a very good information. And in terms of peaks on hour, it is 6.74 peaks on hour. And also we have to take into account the minimum temperature and the maximum temperature, the maximum ventral temperature. So, and the maximum was this value, and we have to take it into account in order to make a very good design. So later we'll see how we can use this information. And also, there's another thing that is very important, the way we put our model, because the way we put our model is very important for the efficiency of our system. For example, if we are here in a place where the latitude is like 20 degrees, is like 20 degrees. So if we put our captor at, for instance, 0 degrees, like on a flat surface, on a horizontal surface, our efficiency will decrease as there is a way to put the captor. So we should put the captor or the motors at an inclination angle that is equal to the latitude of the place. So if the latitude of the place is 20 degrees, so we should incline our module at 20 degrees. If it is at 40 degrees, so we should incline our module at 40 degrees. So it is the way to do that. So why we should do that? Because when we do that, the direct radiation arrive perpendicularly to our captor. But if they are not equal, they will arrive and with an incidence angle that is not 90 degrees. And at this moment, we will have a component of the direct radiation, but not the full direct radiation, not the total of the direct radiation. So in order to harness the total direct radiation, so we have to put our module and in such way that the direct radiation will arrive perpendicularly to the plane of the module. But if the sun is moving, so I said if the sun is moving, it is apparently because when we are on the Earth, for us, the Earth is fixed and the sun is moving. So we are going to consider that like that. So we are going to consider that apparently the sun is moving. So when the sun is moving, at a given moment, if we have the direct radiation, and the moment after, we'll not have it. So the better way to harness the solar energy is to have a tracking system that can track the sun path in order to have the direct radiation perpendicularly to the plane of our module and every instant. But it is not always possible. It exists some tracking system with one axis or with two axes, but the better way to do that is to have the maximum captation on a day. So to have the maximum captation on a day, so we should put the captor at the angle that is equal to the latitude of the place. So this is why we should know where we are, and also we should know that we must add 15 degrees to this value, or do the opposite if we are in fall or winter. So it is it depends on the season. So that's why we can see that for a given season, like in June, the sun path is that line, and let me show you with the last. So the sun path is that line on June, like on this season, and on winter, we can see that the sun path is this. So if we could change this value, it will be better. But for global year, for the maximal captation, it is better to put it equal to the latitude of the place. So here we can see what we were talking about. So in this angle are very important to know when someone is going to make photovoltaic panels installation. So we have to know that this angle, this angle that makes the sun ray with the vertical is the zenith angle, and this angle that make the modules with an horizontal surface is the angle of inclination. So this angle must be equal to the latitude of the place. So this spatial geometry is very important for someone who is going to involve himself in solar photovoltaic installation. And now we are going to see the solar technologies that are available. So there are many types of cells, and there are many types of photovoltaic module. And first, we know that the basic unit of a photovoltaic module is the solar cell, where the photovoltaic effect is carried out. So based on the number of photovoltaic cells, we have various type of photovoltaic panels, and the choice will depend on the available surface, the available fund that is that we have for the project, and also for the kind of application. So we have various type of panels that we can use. 60 panel, 72 cells, 96 cells, and also we have some 144 cells panels that that is available on the market. And according to the type of technology used, we have the monocrystalline photovoltaic panel and the polycrystalline photovoltaic panel. And one way to make the difference, it is those big dot that we have on the mono that we do not have on the poly. And also the color of the mono is a little bit darker, and this is a kind of navy blue that is more lighter, and it is the way to make the difference. But we should know that depending on the level of efficiency that we expect to reach, so we should use one or the other, and depending on the place, because the temperature affects more one and less the other. So also we have another type of photovoltaic module, that is the amorphous photovoltaic module, and also we have the perovskite cells, and there are some other type of cells that are under investigation that are not available on the market. But the more available on the market are the mono photovoltaic module and the poly photovoltaic module. Also, we have some amorphous photovoltaic module that are available on the market. And another thing that is very important, it is to know how to harness the information available on the datasheet of a photovoltaic module. The more important factor on a datasheet is the power. So here we can see for all those models, those are the power, because we are going to base on that information in order to make the design of a system. So once we know the total amount of energy that we need, so we can have the amount of power of our system. And once we have the amount of power of our system, so we can choose which type of panel that we are going to use in terms of power, in order to know the number of photovoltaic modules that we will use in our system. So it is a way to do that. And also there is another important thing. The other important thing is the voltage, because the voltage is important to make the coupling with the inverter, because the coupling voltage should be equal to the voltage of the string. So, and later we are going to see what is a string for those who don't know what is a string, and we are going to see that. And also we have the operating voltage, the operating current, that is very important for the coupling with the inverter. And also if there's a regulator, and if you have a battery energy storage system, so for the coupling, it is very, very important. And also we have the open circuit voltage and the short circuit current. And another thing that is important, it is the operating temperature, because if the temperature is varying, the efficiency of the panel will vary. And also we have those important things, that is here we have the temperature characteristic. It is the way the temperature affect the power of the system. So here we can see each variation of 0.37%, in terms of temperature. So it is the way the power will be affected. So for 1 degree, we'll have a variation of 0.37% in terms of power. And for each variation of 1 degree, so we'll have a variation of 0.29% in terms of voltage. So here we see that the temperature can affect really the power and the voltage and also the current of a photovoltaic system. So we have the advantage to know the range of temperatures of our place or of the place where we're going to implement the solar power plant. So we can know earlier how much the temperature loss will be. So how much will be the efficiency of our system? So we can predict the efficiency of our system in terms of those data. So it is very important to know those information, and those information are, I can say, geometric information that we can use for the physical design of our system, and also to have an idea of the required surface that we will need for the implementation of our system. So here it is the way to see the type of connection of the solar module. So here we have a connection in series. So it is a basic thing, but I do that as a reminder. So as a reminder, the global voltage of a string, it is the sum of the voltage of each solar module. And the current, in this case, is the same current for each one of them. That's right, we should not put together different type of modules. If we do that, one of them will have a receptor behavior, and the other will inject a current to it, and the result, it will burn. So that's why we should not connect in series, neither in parallel, different type of module. And the parallel connection is this. So we have the terminal that are connected together. Positive is positive, negative with negative, and the global voltage is the same for each one of them. And once again, that's right, we should not connect together different type of photovoltaic modules, because the one who has the lesser voltage will have a receptor behavior, and the other one will have a generator behavior, and the other will inject to it energy. And as it was not built for this purpose, so it will burn. So the global current is the sum of the current of each one of them in parallel. So it is very important, and it is a very basic, and with that, we can make a lot of things. So now let's see the PV energy conversion system. So what is a PV energy conversion system? So energy conversion system are configured to transform one form of energy into another one that we can use more efficiently and more effectively. And the topologies depend on the application, what we are going to do, and also the power source that we are dealing with. And a power conversion system requires the use of a set of power electronics converters that we are going to see later to carry out the task. So why it is important? It's very important as to achieve sustainable and efficient use of renewable energy in our daily lives. So we have to design a grid energy conversion system in order to avoid losses. So let us see what are the converter topologies that we can use for implementing a PV energy conversion system. So we have the inverter, the rectifier, the boost converter, the buck boost converter, transformer, frequency regulator. So those are very useful. And as important thing, we should know that a photovoltaic system generates an direct current and DC. So if we have a DC load, so we have to use a DC-DC converter. Why we should use a DC-DC converter? Because we should know that the solar energy is an intermittent energy. There is a lot of variation as we have some climatological reason that can affect the availability of the solar energy. So in order to make a stabilization and to make control, that's why we use DC-DC converter, like the buck boost converter. For instance, the buck boost converter, it is a converter that we use to elevate the voltage. For instance, if my DC load has a nominal voltage of 24 volt, and my photovoltaic system has an output of 12 volt. So in order to connect my DC load, so I have to elevate this voltage with a ratio of 2 times. So I have to implement a buck boost of 2 times that will elevate my voltage. And also the buck boost can do the opposite thing. The buck boost can have a buck behavior. The buck behavior is a when we have, for instance, a load of 6 volt. So if my solar power plant is 12 volt, so in order to reduce the voltage, so I will use the buck mode. But we have this converter separately. We can have a buck, we can have a boost. The boost is for elevator. The buck is to downstep, and the buck boost can do both of them depending on the control that we give to it. And we have to say that are controlled converters. And an inverter is usually used when we have AC load, alternating load. So the inverter helps us to pass from DC to AC, and the rectifier do the opposite, because sometimes we will have to make a back-to-back, like for instance, we already pass to AC, and at some place we have to use a DC load. So we are going to use a rectifier to transform the AC energy into DC energy. So that's why we have the rectifier, and also we have a transformer. So after doing that, we can use an inverter to pass from DC to AC. But what if we have 120 volt, and we have to use 480 volt load? So what we will do? So to use this available energy that is available on 120 volt, so we can use a transformer that can elevate the voltage from 120 to 480 volt. And also we have a frequency regulator that we can use to stabilize the frequency of the system. So, and also we have to think about the protection system that is very useful, like protection against short circuit, protection against surge, against atmospheric discharge, ground fault, etc. There is so many type of fault that we can have on such system, and that we can prevent using protections with breakers, with some useful sensor that can help us to avoid those kind of problems. And also to perform a PV energy conversion system, we're not going to design it in the reality directly. That's why we use a simulation system like MATLAB Simulink, RTLab, and LabVIEW. The RTLab is provided to us by a Canadian enterprise. The name is Opal RT, and Opal RT provide us the RTLab in order to make a real-time simulation in order to analyze the behavior of some system as it was a real system with the clock time. So, and let us see how it looks like a PV energy conversion system. A PV conversion system will look like that. And so, for example, we have the PV array, and after we have a protection system, and we have an MPPT that we use to track the maximum power as the solar energy is intermittent. So in order to deal with the fluctuation, we use an MPPT. And this boost converter is, as I said before, is to adjust the voltage in order to put it at the level of the input of our inverter. So that's what I was talking about. So we can address the coupling voltage. So if the coupling voltage is not, if the output voltage of the PV array is not equal to the coupling voltage of the inverter, so we should use a DC-DC converter in order to make this adjustment. And also, if we want to make compensation or like to make load leveling, peak shaving, to address power quality for more reliability, we can use a battery energy storage system. And to do that, we use a buck boost converter. Why we use a buck boost converter? So we can imagine if the voltage at this side is like 24 volt, and if our battery energy storage system has an operational voltage of 12 volt. So what we can use a buck boost. So when we are going to store energy, so we are going to downside the voltage with the buck mode, with the buck side. And when we are going to provide energy to supply and to help the solar power plant, when the available irradiation is not higher, so we are going to use the energy stored in order to fulfill the system. So we are going to use the boost mode in order to elevate from 12 volt to 24 volt. It is an example. It can be different. The ratio can be different, and the level of voltage can be different. It can be from 224 to 48 and much higher or less. Yeah, here we have the inverter when we leave this DC side. And also, if we have DC load, we can connect the DC load at this side. And for the other type of load like AC load, so we should use an inverter that can help us to pass from DC to AC, from direct current to alternating current. And also, we have this protection equipment that we can use, and this is a meter in order to see what we have from this side. And this is a panel where we arrive with all the line, like the available energy from the PV sources. And if we are connected to the grid, the energy available from the grid right here. So we can select what we are going to use. If we're going to use both of them, if the PV energy is not enough for the AC load, so the rest come from the grid. And if what we have from the PV array is enough for the AC load and the DC load, so the rest we can inject it. But it depends on the policies with the supplier that we have in our local. It depends on the local provider. So let us see. And there are some commercialized technologies that we can use, and there's a commercialized technology. Some of them are available with included MPPT tracker and other without MPPT tracker. Some of them with galvanic transformer, and some of them can give you a wider range of coupling voltage, and some of them can give you a specific range of coupling voltage. So it depends. So now for the PV sizing. For the PV sizing, there is those information that we need. Information about the customer's load, like the electrical consumption of the customer. And we have to harness the geographical data of the site in order to have climatological data like temperature, like wind speed, like irradiance. It is very important. And also we have to take into account the customer requirements, like the number of hours of autonomy, the type of PV system, and if it is for industrial, if it is for residential, we have to take all of those information into account. And also with all of this information, we can approximate the peak power needed by this client. And with this, we can make the choice of technologies, like the type of models, the number of models, the power of the motors, the efficiency of the motors, and the type of inverter according to the coupling voltage. So we can design the inverter, and according to the power, we can design the inverter, the regulator, and the system configuration, like the number of string and the number of motors, and we can calculate the performance of the system, and later make the design of the system physically, and design the mechanical structure. That is another part of the PV sizing. The PV sizing that is very big. So this is an example of a PV array. So this PV array, we can see what we have here. We have 5 strings with 4 modules in series. So let us guess the power of this PV array. So this PV array of 5 strings of 4 modules in series. So globally we have 20 modules. It is the first information. And the voltage of a string is the voltage of a module multiplied by 4. And the current of the string is the same as the current of one module, as we have seen before. And later, other information, the power of the string is the power of a module multiplied by the number of modules and the string. So it is the power of a module multiplied by 4. And let us see the voltage of the PV array. The voltage of the PV array, as all of those strings are put together in parallel, so the voltage of the PV array is the same as the voltage of a string. So the voltage of the PV array is equal to the voltage of a string. What is the current of the PV array? The current of the PV array is the current of a string multiplied by the number of strings as they are put in parallel. So it is the current of a string multiplied by 5. And the power of a PV array is the power of a string multiplied by the number of strings. So it is the power of a string multiplied by the number of strings, that is 5. So this is the power of the PV array. So we can see that the power of the PV array is the power of a module multiplied by the number of modules. So once we know that, we can do a PV design. But first of all, we have to determine according to the consumption to the historical consumption of the client, the amount of energy required by the client during a day. So we can know the available energy during a day according to the irradiance informations. So once we have the time, the range of time where the sunlight will be available, we can approximate the power of the system. Once we have the power of the system, so we can determine with this line of calculation the amount of module and the power of one module. So we can inverse the calculation in order to find the characteristic of one module. So once we have the characteristic of one module, so we can design the whole system. And once we have the PV array information, we should know that the voltage of the PV array should be near the voltage of coupling of the inverter or the regulator. So once we have that, we can design a PV system. So this is the way to do that. So look, this is a summary of the calculus that we have made before. So let us see that the power of the inverter can be designed according to this calculus, like a 0.9 times the power of the PV array. And this is the number of photovoltaic module per string that is equal to the nominal voltage of the inverter divided by the voltage of the module. So here we can know how much module we should have in a string. And the power of the string is the power of the module by the number of photovoltaic module per string. And the number of photovoltaic string, to know how much of photovoltaic string we should have, it is the power of the PV array divided by the power of the string that we already know how to find. And the number of photovoltaic module is right. The number of photovoltaic string multiplied by the number of photovoltaic module per string. It is a way to find the number of photovoltaic module. And as termination, PVM is a PV module, photovoltaic module. PVS is a PV string, that is photovoltaic string. So this is the way to do the PV sizing. So it is a very easy when we dominate this information. For instance, this is a little summary of a system that we have designed. So we determine the number of module per string, the number of photovoltaic module, the number of string, that was 9, the number of PV array, it is for one PV array, and later we have to determine this characteristic of each part for the photovoltaic module, for the photovoltaic string, and for the global photovoltaic PV array. So the maximum power, the current, the voltage, the operational current, the operational voltage. So we have to determine for each part of them. So the summary is based on this calculus. So to conclude, so we have to say that photovoltaic technologies are under researches, and there is a lot of promising technologies that are going to be available on the market. Here at the university, at the National Autonomous University of Mexico, we are doing a lot of investigation on this field, and there is a big challenges as the challenges are related to the application to the trains, and one of the most challenges it is the energy transition that we should contribute with photovoltaic system in order to contribute to the reduction of CO2 emissions, other gases emissions. So it is important to carry out those investigations. And we have to take into account the advantages of the photovoltaic system, and mostly it is the fact that there is no fuel consumption, no noise, no CO2 emissions. And also, we are looking forward to reduce the impact of the disadvantages, like increase the efficiency in order to reduce the required surface, and also to reduce the cost. And also, we have to take into account the type of application, if we should use a photovoltaic system or thermal solar system. And also, there are some useful software that we can use in order to make the design. There's Homer Pro, there's Helioscope that can help us to make the design in order to see how effective our system will be. There's a PVC and Simulink that help us to design solar photovoltaic system or energy conversion system, a lot of things. So thank you so much, everybody. So if you have a question, I'm ready. Lombai, Longa, let me see. So thank you, everybody.
Hello.
Thank you, Robenson Jean. Lumbai, you ready to go?
Yes, I'm ready to go. Hello, Doc.
Okay,
How are
Lombai.
you?
Fine.
Good, good. Yeah, thank you for your presentation. Although we are like you with that, but my question is that inverter can also use the inverter in like industry, like in a big institution, like in the hospitals.
Your
Does the
question
power, does it have the power to that you can use it for those like the big institution as well?
Okay, yeah. You ask if photovoltaic system has the power to supply like an hospital.
Yes.
Okay,
Yes.
I understand. Okay, let me tell you that photovoltaic system is very, very powerful, and it is a mature technology. So I think your question is more about that, if it is a mature technology. Yes, it is a mature technology, and I have the possibility to make this experience where in my country, I'm Haitian, and Haiti, I did the planning for three cities, for the electrification of 3 cities, and the power plant for all of the cities, all of these 3 cities were hybrid power plant. Hybrid power plant means that we use a diesel generator with the photovoltaic system. The photovoltaic system is to operate during the day, and the diesel power plant, as the sun is not available at night, so we will use the diesel power plant. But the diesel power plant is in the case the battery energy storage system is not enough to manage the load. So once we have the peak hour, we will use the diesel backup in order to help the photovoltaic system or the battery energy storage system. So it is a very mature technology. And also I had the possibility to design a system for an hospital at the north of Haiti. And this hospital is being operated only with photovoltaic system. We have the diesel group just in case if we spend like 2-3 days without sunlight, if there is an hurricane, so we will use the diesel group. But outside of this situation, it is only solar technology. It is a very mature technology.
Okay. All right. Thank you so much for the answer.
Yeah. So I have some other question. There is a lot of people. Ngongo asked me if it is possible to have an example of sizing for a home application. Yeah, Ngongo, yes, there is the possibility. So this was the sizing of a home application, so that we made. So, but when I say a home application, it is no, this was for an enterprise, like commercial. So, but the same calcul, there's information, you can use it for personal use. So what you will do is like doing a load studies, like so you can have this related to your electricity bill. Related to your electricity bill, you can know what is your monthly or daily consumption. So you can have this information. So once you have your daily consumption, and also you can use this website, the website of La NASA. Let me see. Okay, yeah, this website, you can use it in order to have climatological information like temperature, and also you can have irradiance information in order to make something like that. So you will proceed to this table in order to have the irradiation of in your place for every month, and later you will see the available, the number of hours where the sunlight is available. So you can see the peak sun hour like that, like the number of hours where the sunlight is really available. Okay, and after, so with this information, if you divide this information by this information, you can see the power that you need for each month. So you can have an average for the year. So once you have the average power that is available during the year, so you can use the energy that you need. So if you know the energy that you need for your load, and you know the available power, the daily available power, so you can divide the energy that you need by the available power in order to know how much hour of autonomy that you will have normally. And later, you can know the power of your system. And once you know the power of your system, you can use this information in order to know how much PV panel that you will need, what is the power of the inverter, what is the number of string that you will need for your personal photovoltaic system. And later, you will design the potential system. But I have to tell you, there is it is not so easy or simple to design the protection. So the protection system also is another part that is a whole part of investigation that you should know. But there is a simple available information for knowing how to design breaker for simple circuit in order to protect your photovoltaic system. So it is something that you can do at home. Some people do this with one panel, two panel, for instance. And one day, if the available power is for 5 hours, so in 5 hours with a panel of 300 watt, so you will have 300 watt time 5 hours, so it will give you like 1,500 watt hour. So if in one day you use less than 105,000 watt hour, so your system is quite enough with one panel. So it is like that, but for much more, you will use more panel. It's like that. And later, after Ngonko, I don't know if I can take everyone's question.
There is a question in chat from about half an hour ago from Onias Pofu. In most of the solar energy plants that I've seen, there's a generator installed. What is the use of the generator in the plant? And does the capacity of solar panels to attract the sun reduce? So if it is so, after how long can this happen? So why would you have a generator installed?
Okay. I can help you with this information. So let me, I don't know if I can present you something else, but let me see. Yeah, exactly. And most of solar energy power plant, there is a generator installed. Why do we have a generator installed and a photovoltaic system? And the contrast is the fact that solar photovoltaic system is a renewable energy that that we use in order to reduce fuel consumption, in order to reduce, but I said reduce, in order to reduce fuel consumption and to reduce CO2 emissions. And why do we install a generator that uses fossil fuel? So this is because the solar energy is intermittent. So there is a possibility that at some moment of the day, the sunlight is not available due to climatological reason, like a cloud, like other things. So that's why, in order to prevent these energy cutting, so we install the generator. So the generator is like a backup. It's like a backup for the system. In the case the sunlight is not available, because we know that if we don't have sunlight, we don't have electricity. So that's why we always have the generator. It is as a backup, because if you do not have the backup, so what will happen when on your surface there is a cloud? Or if we spend like 1 day, 2 days, 3 days without sunlight, so you will not have electricity. So in order to prevent this kind of failure, so we install the generator. And the other part is does the capacity of solar panels to attract the sun reduces? If it is so, after how long can this happen? Yes, the capacity of the solar panel can reduce. So it is better to say the efficiency of the solar panel. The efficiency of the solar panel can reduce after for this depend on the technology, this depend on the brain. So the brain will tell you after how many years you should replace your solar panel. Some of them can tell you you should replace your system after 10 years, some of them after 15 years, and some of them after 20 years. So in a software like Homer, when you're going to design a system, owner will take into account the cost of replacement of the solar panel. And here at the institute where I was studying, I had friends who did these studies to see in a short of time how much the ultraviolet ray, the UV ray affect the lifetime of a solar panel. And I have to tell you that the lifetime of the solar panel is being reduced due to the UV effect of the sun. So yes, the capacity will reduce, better the efficiency of the panel will reduce. Another question?
There's another question from Rosemary Bargan. What is the lifespan of a panel? And can the spare parts be recycled?
Can you repeat for me, please?
What is the lifespan of a panel? How long does it last? And can spare parts be recycled?
Okay. You're asking if after the replacement, if we can recycle the panel. Hello?
Yeah, does like a solar panel last 5 years, 10
Yeah.
years, 20 years?
Yeah, so after this process and what someone's supposed to do is replace the panel by a new panel, but the used panel, so normally some brand, depending on the contract that you have with the brand, you can return the panel to the brand, so they will not reprocess those panels, but it is more in order to prevent environmental impact with this panel that can constitute trashes at the environment. So it is better to return those panels to the brain. And in some place, what people usually do is like they sell these panels before they lose all of not all of their capacity, but before they lose a large amount of percentage of the values or of their efficiency. So they sell it, and some people are very glad to buy this panel at a better price. But the best thing to do is to return these photovoltaic modules to the manufacturers. So it depends on the contract that we had with the manufacturers. And in some projects in which I participate, normally this is what they do. More question. It is possible to have, okay, it is a number.
There is a question. Is there such a thing as a floating photovoltaic system?
Can you repeat, please?
There's a question about the floating voltaic system. What is the trend of the floating voltaic system?
Okay, the trends. So the trends are as someone else has a question?
Oh, yes.
Okay.
How much time do you have? Because we're already 20 minutes over.
20 minutes. I think it is a 1 hour class. 1 hour.
Yeah, sure. Do you want to limit it to one more question and then just come back next time?
Yeah.
Okay.
Okay. So
this will be the last question.
Hello.
So
oh, by the way, can you share your email so that people have questions?
Yeah.
Okay. Okay, so I guess you're answering the question about the floating voltaic system.
Yeah, there's this question about the trends. So the trends is the leading technology in renewable energy, wind and solar energy. And as I said it at the beginning, so let us see. So yeah, so solar in 2021, according to Ember, that usually give an annual report. So the contribution of solar energy and global electricity production were 3.7% on 2021, and like 8 years ago it was 1.1. So it is being increased. So, and if someone need information about the trends of solar technology, you can consult the Ember annual report. That is very useful, and also the IRENA, the IRENA annual report, and the BP global report also. So you can see the trends of the renewable energy technologies. But now the leading renewable technologies are solar and wind that come first, and after we have the others. And the last question, the message.
Do you see the last question? You can choose whichever one you want.
Let me see on the message. Okay.
Lots of questions, actually.
Yeah, okay. Thomas Okelo, is there any large-scale innovation for DC to DC conversion other than 12 to 20 or to 48 going on? No, in fact, when I was talking about 12 to 24 or 24 to 48, it was an example. So these are depend on the ratio of your DC-DC converter. For example, the most important thing is the ratio of your DC-DC converter. For example, if your DC-DC converter has a ratio 3 times, so if the input is 10 volt, the output will be 30. But I was talking about a DC-DC converter with a conversion ratio 2 times upper. So if the input is 12 volt, the output will be 24. But depending on the control, the duty cycle of your DC-DC converter, so the ratio can change. For instance, if I give a 15 volt to a 2 times ratio converter, so the output will be 30. But I can do a converter with 1.5 ratio upper. So if I give it 10 volt at the input, the output will be 15 volt. If I give it like 100 volt at the input, the output will be 150. So the most important thing is not the input voltage or the output voltage, it is the ratio. But also there's a range of voltage that we can use for a given DC-DC converter. But what you can have on the market as the DC-DC converter is what we usually call the regulator, and some regulator has included a boost converter or a buck boost converter, and that is what help us to store energy in a battery. So on the market, what we have, it is the DC-DC regulator that we commonly see.
So the students are asking for your email if they can, because they're going to be writing assignments. So that if they have a question as they're writing their assignments, can they send you an email?
Okay. 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 So let me type it in the chat. So
Make sure it goes to everyone.
okay. Everyone in meeting. Yes, this is my email, so you can contact me, and you can have an answer for whatever your question and the question that I didn't have time to answer. So you can ask. So thank you for your presence, and thank you for everything. So
Thank
have a
you,
good day.
Robenson Jean.
Thank you.
Very, very, very good information. Let's just put it that way. This is very valuable. That if anybody wants to work in solar energy, this is very valuable information.
Yeah, and I'm sorry to the one who asked me the question if the solar technology is mature, or if we can use it for a bigger hospital, for instance. What here I have the design of a photovoltaic system for 2 hospitals, but unfortunately I cannot share the design as due to some policies between me and the contractors. So I'm very sorry, but it will be very, very useful. It will be very useful to see that, but unfortunately I cannot
you're giving away
right now
company secrets.
Yeah, that's why, unfortunately. Yeah.
Can't do that. No.
Yeah.
You would get into trouble.
For me, there is no problem, but due to the contract that I have, but I cannot do that. But there's a rule system, and also with diesel generator backup started, and how to switch between the generator and the photovoltaic system and the backup, like the battery energy storage system, a lot of things. But maybe another presentation related to that. Thank you so much.